Guys, I did some of the legwork on this already. I wanted to write down a few things just so that I could remind you of the things we talked about in class. I guess I can underline them while I go through it real fast. I'll use some lighter colors to point them out. All right. We were talking about quadratic equations or quadratic functions. And so at one point or another, I told you it was in this form here. F of x is ax squared plus bx plus c. And I need those coefficients to find the center point, my axis of symmetry, of my parabola. The axis of symmetry is the center line of the parabola. And to find it, I use a small portion of the quadratic formula. And what happens is I find this, and it becomes that axis of symmetry also is the x value of the vertex. So when you're trying to find the vertex of a parabola, the x value is always your axis of symmetry. That's where it lies on the x-axis. And then your y value is always going to be your max or your min. Right? So let's go ahead and move up here. I've already done this work for us. I didn't feel like taking a whole lot of time just to show you this stuff, how I did it, how long it takes, because it takes me a long time to write this stuff out, and I don't want to waste a lot of time while I'm writing, so I'm going to show you what happened. Just like we did in class, I just FOILed this whole thing out. I just multiplied everything out, then I distributed the negative. So here we go. I wrote it out. Negative x minus 1 times x minus 1, right? There are my two binomials. That's squaring that term right there, minus 3. Then I did the FOIL. So x times x is x squared. X times negative 1 is negative x. Negative 1 times x is another negative x. And then negative 1 times negative 1 gives me positive 1. Well, I still have some multiplication to do with my order of operations. I still have this negative sign up here. So I'm going to distribute it to every piece inside. I combined my negative x and negative x to give me negative 2x. And now I'm going to distribute my negative. So negative times x squared is negative x squared. Negative times negative 2x is positive 2x. And then negative times plus 1 is negative 1 or minus 1. And then I tack on the minus 3. Now, I can combine these guys. So I did. So I have negative x squared plus 2x minus 4. And I'm set here. I have an A and a B and a C. Everything's great. So A is negative 1. B is 2. So I go up here and I use all this information up here, and I'm going to put it into my axis of symmetry formula, right? So negative B, which is 2. Negative times 2 is negative 2. 2 times A, which is negative 1, remember it's negative 1, is also negative 2. So negative 2 divided by negative 2 is 1. So my axis of symmetry, or the x value of my vertex, is 1. What I do next is I take that 1, my x value, I plug it back into my original function, right? So I can plug it back in here. 1 minus 1 is 0, minus 3 is negative 3. Or I can plug it into this multiplied out version of it. So the negative 1 squared is negative 1. Because you have to square it first and then put the negative on. Then 2 times 1 is 2 minus 4. So negative 1 plus positive 2 is 1. 1 minus 3. 1 minus 4 is negative 3. So there is my, I'm going to call it my max, because this is a sad face or negative function, my negative parabola. Now, I know because I multiplied this sucker out, and when I multiplied it out, this 4 here is my y-intercept. So I marked that in advance. But what I'm going to show you is that this particular function does not cross the x-axis, and here's why. Its maximum is at negative 3. Well, that messes everything up, doesn't it? So let me get rid of this, and I'll show you what the graph looks like. This was my vertex. It just says it. It says it right here. 1, negative 3. So I marked it. And then I graphed from there because it was negative. All right, and just like the other graphs, it's just the same. All right, where's my y-intercept? Well, we figured it was at negative 4. So I just reflected it on the other side and drew my parabola accordingly. All right, does this function cross the x-axis? No, it does not. So I can write not applicable, or I can write does not exist. This is a very calculus-based idea, right? When we get to limits, does not exist. And that's really it, guys. We'll go through a couple more tomorrow, and then we'll really start moving on. All right, thank you for your time, and good luck. I know it's annoying, but you're going to get through it.